Chalo guys, let's start because I don't think anybody else will be coming now. So we have started with differential equations in the last class. We know what our general differential equation looks like and what is the order and degree of a differential equation, right? Now degree only exists in case of when our equation is polynomial and derivative, right? So if the equation is not a polynomial and derivative, in that case, uh, the degree will not be defined. The order will still be defined, but the degree won't be defined, right? So let's solve few more problems. And you can ask me if you had any doubt in exercise 9.1.
Yes.
Otherwise, if you have doubt, feel free to ask. Okay.
No, sir, I don't.
Yeah. Can you tell me the degree and order of this differential equation?
Order is two.
Order is two, right? And degree,
It's not defined.
not defined, right? So we only care when our derivative is coming inside either trigonometric functions or exponential functions or logarithmic functions. So function may be of any kind. Each of these individual form, by the way, this is d2y by dx square, right? Y double dash. So each of these function is a problem in itself. Yeah, I mean each of these terms on the right hand side. Hence, the degree will not be defined in such cases, right? So this is basic introduction of differentiation. We will be dealing mostly with the equations that has one part as a derivative, and then we will be dealing with simple differential equations, not the complex ones. Like this fourth equation is a very complex differential equation. This won't be solved very easily. So we will not be solving these. Uh, so before uh, first of all, before we move further in the chapter, let's first understand the chapter a bit more. So how are we forming these differential equations? Let's say if we talk about this fourth equation, तो ये भी यार किसी न किसी कर्व की इक्वेशन से ही बनी होगी. We had some equation. For example, I can make a differential equation of all the straight lines, right? Okay, so I would show you how do we form a differential equation. Uh, okay, before that, let's solve an example first for doing it. Uh, yeah, so Austin, we have just started. Uh, we have only solved one example, this fourth example, in which the order was 2 and degree was not defined because the equation, the given differential equation was not a polynomial in derivative, right? Uh, so we will start, I mean, moving further in the chapter differential equation. So we are starting with this topic, general solution and particular solution of a differential equation. Right? So first understand what is given. First understand it through an example first. Uh, let's take Okay, so let's consider this a differential equation for now. I mean, this is a differential equation, right? Because this equation is involving derivatives as well as some functions of x and y, right? Uh, all of these kind of equations are differential equations. So this is a differential equation, right? And now take this function y is equals to e to the power minus 3x. Y is equals to e to the power minus 3x, right? Now, if I take this function and if I calculate this dy by dx and d2y by dx square, okay, let's calculate dy by dx first. So dy by dx, if I differentiate this whole equation with respect to x, then left hand side will be dy by dx, right hand side will be e to the power minus 3x will be e to the power minus 3x, because e to the power x is e to the power x. Then we will move on to minus 3x. Minus 3x will be minus 3, right? Now again calculating d2y by dx square, that is, I'm differentiating this equation again. So this minus 3 will be as it is, because this is a constant in multiplication. Now I will again differentiate e to the power minus 3x. This will be e to the power minus 3x into minus 3, right? So this whole value will be 9 e to the power minus 3x, right? Now let's use these expressions in this differential equation. Okay, use these different expressions in the given differential equation, and you will see that these expressions will satisfy the differential equation. Okay, let's check this. So if I use this, using them in first, okay, if I use them in first, so d2y by dx square, in place of d2y by dx square, I can put 9 e to the power minus 3x, right, plus dy by dx. So plus minus of 3 into e to the power minus 3x, right, minus 6y. Y would be e to the power minus 3x. So this would be my LHS, right? Now, if you calculate this LHS, this is 9 e to the power minus 3x. This is minus 3 e to the power minus 3x. This is minus 6 e to the power minus 3x. So in total, it would be 9 e to the power minus 3x, and then they will cancel each other, and the resultant will be 0, which is equal to RHS. Which means what? It means that this y is equals to e to the power minus 3x is a solution of the above differential equation. That if you take y is equals to e to the power minus 3x, then a differential equation that can be formed for this curve will be d2y by dx square plus dy by dx minus 6y is equals to 0. So if a given function satisfies a given differential equation, in that case we say that the function is a solution of that differential equation. For example, in this case, y is equals to e to the power minus 3x satisfies the given differential equation if you put the required values. So we
Sir,
can say, yeah, shall we?
so like it will be equated to 0.
Which will be equated to 0? No,
Like
we are
if we are
trying to prove
substituting,
the L,
so
we are just trying to prove LHS is equal to RHS.
okay.
Yeah. So whatever is in RHS, we will be trying to get that thing, right? It can be, I mean, 3x. It depends on the equation actually, but whatever is in the RHS, we are trying to equate the whole LHS to the RHS. So, I mean, first of all, understand that this y is equals to e to the power minus 3x is a solution of the given differential equation. And how can we say that? Because if we take the required values and put that in LHS, then LHS is definitely equal to RHS, right? This is the first thing. Now, the second thing is, how do we find the solution? I mean, if we are given a differential equation, can we find the solution of that differential equation? Yes. I mean, we tend to know some of the methods that can help with solving differential equations, but still we don't know the solution for every differential equation. I mean, there are a lot of differential equations out there which are unsolvable, and which can't be, I mean, there are no methods to solve them yet. But we will be dealing mostly with first order and first degree differential equations, right? Which is the basic form of differential equation again. So we will be solving these differential equations, right? And we will be trying to find out the solutions. So first of all, understand that for every differential equation, there will be a solution, right? We will be finding that solution, but we will be doing that a bit late. In the next two exercises, we will be focusing on, first of all, two things. What is the concept of general solution and particular solution? One thing is this. And then another will be how to form a differential equation. How to form a differential equation. If we are giving you a simple equation, then how do you form a differential equation for that curve, for that equation, right? So first of all, we will learn this, and then we will get to know the actual part of differential equation, which is to solve a differential equation, right? So most probably the question will be from that portion only. There are three methods that is described in the book to solve differential equations. So in all probabilities, I mean, the question will be from there. But sometimes what happens is that there can be a 1 or 2 marker question from this portion. So which is, and this portion is also pretty easy. It's not like it is a very tough thing or something like that. So you can easily score 1 or 2 marks if you just listen to the class. Right? Yeah, so let's first understand what is the concept of general solution and particular solution. So for example, let's say, I mean, this is very easy to understand with an example only. Okay, before we head to the example, let's write, therefore y is equals to e to the power minus 3x is a particular solution. Now I'll be talking about particular solution and general solution also, but for now you just write it. Y is equals to e to the power minus 3x is a particular solution of the given differential equation, right? Now let's understand what is general solution and what is particular solution from an example first. So okay, focus on this. Y is equals to mx plus c. What is this? This is general equation of a line. Why are we saying this is a general equation of line? Because M and C, which are basically constants, but they are arbitrary constants. Arbitrary constants mean they can change values. They will certainly change values for different straight lines, right? With the help of values, with the help of different values of M and C, like you take M1, you take M2, and you form different combinations of C, you will get all the lines that exist in a plane, right? So y is equals to mx plus c is a general equation of a line. But if I say y is equals to 3x plus 4, then y is equals to 3x plus 4 is a particular line, right? We know this line. We can in fact draw this line on a graph. Same is the concept with particular solution and general solution.
Sir.
Yes.
Sir, what are arbitrary constants?
Arbitrary constants are those constants. I mean, the value of these arbitrary constants will be a constant value. Like for example, y is equals to mx plus c. M is a constant. In every equation of a straight line, m will be a constant, c will be a constant. But see, this is a different equation. Then again, y is equals to 4x plus 3. This is also a particular line. Now you can see that m and c both are constant in each equation, but they are changing the values for different straight lines. Like in the first case, m is 3, but in the second case, m is 4. They are still constant. They will be constant for a particular straight line. But m has a range of values. m की वैल्यूज तो हम अलग अलग कुछ भी ले सकते हैं, क्योंकि हम बहुत सारी वैल्यूज m की ले सकते हैं, बट स्टिल वो एक कांस्टेंट ही रहेगा हमेशा. ऐसे ही कांस्टेंट को हम आर्बिट्ररी कांस्टेंट्स बोलते हैं, which can take different values
Which
to
change
different,
value for a particular line.
which basically, I mean, these are constants only, but they represent a family of curves. In this case, M and C are two important criteria of a straight line, which defines basically a straight line. So M and C are constants only, but they are defining every equation of line. For a particular M and for a particular value of C, you will get a straight line, right? So arbitrary constant, simple constant ही होंगे, बस उनकी बहुत सारी वैल्यूज पॉसिबल है, राइट? या फिर ऐसे भी सोच सकते हैं कि जितने भी जनरल इक्वेशन ऑफ लाइन को लिखने में कांस्टेंट्स यूज करते हैं ना, मतलब जनरल इक्वेशंस लिखने में कांस्टेंट्स यूज करते हैं, वो सारे के सारे कांस्टेंट्स आर्बिट्ररी कांस्टेंट्स ही होते हैं. Every constant used in writing any equation, all those are arbitrary constants.
Okay.
Yeah. So same is the concept with general solution and particular solution. If you say general solution of an equation, then in that case these arbitrary constants can be involved. For example, uh, hmm, yeah. So for example, let's take this differential equation only. For example, d2y by dx square plus dy by dx minus 6y is equals to 0 is a differential equation given to you, right? Now you take y is equals to e to the power minus 3x, right? And this equation, y is equals to e to the power minus 3x, basically satisfies your whole differential equation. Now, let's say in place of 3, if I use a constant a, e to the power minus ax, right? Then that a can take different values, right? Because that is a constant. And right now I'm using arbitrary constant, because arbitrary constant का मतलब यही है, देखो कि ये constant value ही है. Now a is playing a role of constant here only, right? But still, I mean, it's not a particular value. Like in this case, a is 3. If a has a value, then it is said to be a particular solution. If that a or that constant is represented with a with an alphabet, in all such cases, you have a general solution. So y is equals to e to the power minus 3x is a particular solution of the given differential equation. While, you know, if you take e to the power minus mx here, and if you put, I mean, if you change the equation, and let's say there is, okay, I'm going to write it in the bottom. Y is equals to a into e to the power minus bx can be a general solution of the above d. So it means that we are saying y is equals to a to the power a into e to the power minus bx, that is a, and for some a and for some b, for some a and some b, right? Some real value of a and some real values of b, y is equals to a into e to the power minus bx can be a general solution for this differential equation, right? So whenever we are talking about general solutions, we will be specifying some alphabets, or we will be leaving some constants in the form of alphabet, right? And whenever we are talking about particular solution, then we are giving those alphabets some particular number, like y is equals to e to the power minus 3x is a particular solution. Why? Because in this case, a is 1 and b is 3. Okay. So this is the basic difference between particular solution and general solution. And what I mean, your main job will be to verify whether a given equation is a solution to the differential equation. So you will be given a differential equation, and you will also be given a function, right? Y in form of x or x in form of y, some kind of like that, right? And then you will be asked to verify whether the given equation is a solution of the given differential equation. So for that, you will have to take this approach only, whatever we have done in the above example. You have to follow the same steps, and you will be reached to your answer, right? So, but before that, let's first write general solution and particular solution. Um, the solutions which contain arbitrary constants and then your particular solution of D would be all those solutions which are free from arbitrary constants. All solutions which are free from arbitrary constants, right? So let's solve some of the questions which will be asked in this exercise. These are pretty easy. You just have to know the basic differentiation and basic maths. So there will be a function given to you. Like in this case, y is equals to e to the power x plus 1 is a function. And then y double dash minus y dash is equals to 0 is a differential equation given to you. So you basically have to verify whether this function is a solution to this differential equation or not. In order to do that, you will have to perform these basic steps. You will first observe your differential equation. In this differential equation, you will see which derivative we need to actually calculate. Like in this case, you can see that y dash and y double dash are given. So y dash and y double dash are given money. We have to find out dy by dx, and we also have to find out d2y by dx square to solve this differential equation. And how do we find dy by dx and d2y by dx square? From this function, right? So we will observe the differential equation. We will see up to which order we need to differentiate the given function. Like in this case, up to second order, we will differentiate the function up to second order. So we have y, we will first find out dy by dx. Dy by dx will be differentiation of e to the power x, which is e to the power x, plus 1 will be plus 0, because this is a constant, right? Then again, d2y by dx square will again be e to the power x, right? You can write these equations as 1 and 2, right? and you can write this equation as star. So using 1 and 2 in star, we can directly put these values. So y double dash is e to the power x from equation 2, and y dash is also e to the power x from equation 1. So we are just considering LHS. You can see that the LHS is equal to 0, which is again RHS. So if LHS is equal to RHS, we can definitely say y is equals to e to the power x plus 1 is a solution of d y double dash minus y dash is equals to 0. So verifying for a function to be a solution of the corresponding differential equation is quite easy. You just have to perform the basic differentiation and basic maths, basic calculation. This is a good question. You guys try to prove this, please, quickly. Hanji, is it done? Anyone?
Sir, I'm doing.
Okay. So if we observe the differential equation, we just need to calculate y dash, right? And y dash means dy by dx. So dy by dx, to calculate dy by dx, we have to apply product rule, right? So differentiate x, differentiation of x is 1 into sin x as it is. So it's just sin x plus x as it is. Differentiation of sin x is cos x, right? So use this first in star. If I use this first in star, in that case, this LHS becomes what? This is x into y dash is sin x plus x cos x, right? So this becomes x sin x plus x square cos x, right? Now you can see that x sin x is nothing but y. This is y, right? X sin x is y plus this is x square, and cos x, you can find cos x using this sin x, right? As y is equals to x sin x, it means that sin x, the value of sin x is y by x, right? So the value of sin square x will be y square by x square. And from here we can find out cos x. Just wait a minute. Yes. So from here we can find out the value of cos x. So I'm just directly writing the value of cos x. So cos x would be 1 minus, in fact, root over 1 minus y square by x square. You can even write that as, if you take the LCM, so this would be 1 by x outside the root, and then this will be x square minus y square. So if you put that value, then 1x cancels out 1x. So this is y plus x times root over x square minus y square, which is again equal to RHS. Right? So this is how we can prove just with the help of the function. Right? Try to solve the third one. Try to verify the third one. Let's see.
Sir,
Yes,
we can take LHS or RHS.
anything, yeah. I
Okay.
mean, in this case, third, you can't take RHS obviously because RHS is itself zero. No? you should start with LHS and you have to prove that LHS is also 0. No? Yeah, guys, are you able to solve this one? Okay, x plus y is equals to tan y, right? If I observe, uh, yeah, so if I observe the differential equation, then I only need y dash. That is, I just have to differentiate the whole equation with respect to x once, right? So let's find dy by dx first. So differentiating this with respect to x, this will be 1 plus this will be dy by dx. Then to the right hand side, tan, differentiation of tan is anyone? Anji, differentiation of tan,
Sec square
sec square y. And then differentiation of y also, which will be dy by
dy by
dx.
dx.
Yeah. So that is how we will find out dy by dx. We will take this this term to the left hand side, either this term to the left hand side or this dy by dx to the right hand side, right? So I can write it like this. And sec square y minus 1 is tan square y. So this can be written as tan square y, right? So if you observe, then we can write dy by dx as 1 upon, you can write this as tan square y, and then you can take this tan square y to the left hand side. So this will be 1 upon tan square y is equals to dy by dx, or dy by dx is equals to 1 upon tan square y, which is what? Cot square y. So dy by dx for this function is cot square y. Right? Now the problem is you don't have y. If you observe, in this case, you don't have y. What is the value of y? You won't be able to find out y actually here. So what will happen is that yeah. So from this portion, if you let's take the yeah. Is the equation correct? I think the equation is correct. Yeah. Oh yeah. Equation is not correct. This is actually tan inverse y. So it's okay. Okay. So this is basically not tan y. This is tan inverse y. Okay. This is tan inverse y. And if I differentiate tan inverse y with respect to x, so first the differentiation of tan inverse, right? The differentiation of tan inverse is 1 upon 1 plus input square. Input is y. This will be 1 upon 1 plus y square. This is the differentiation of tan inverse. Then differentiation of y, which will be dy by dx, right? So we can take dy by dx common, and then this will be 1 upon 1 plus y square minus 1. And this can be further solved as 1 plus 1, this will be 1 plus 1. So your dy by dx can actually be written as y square plus 1 upon y square into minus, which will basically be minus of 1 plus 1 upon y square. This will be your dy by dx. And if you convert this equation, you will get the required equation, whatever is written here. If you just convert this equation. So this is y dash, right? Okay, let me show you the whole equation. Let's forget this. If you simplify this, okay, if you simplify this, just the right hand part, this part. So this will be dy by dx into 1 minus y square divided by 1 plus y square. Right? 1 will get cancelled out. This will be minus y square upon 1 plus y square. And I am sending this to the left hand side. So 1 plus y square or y square plus 1 will become numerator, and minus y square will become denominator. So this minus has been taken outside. This is like this. Okay. Now I am multiplying this y square with this. So can I write this y square into dy by dx as y square y dash is equals to minus times of y square plus 1. Now, if I take this to the left hand side, this minus will get multiplied with y square and 1 also. So this will become minus y square minus 1. If I take them into the left hand side, this will become plus y square plus 1 is equals to 0, which is the required differential equation if you see. So from the equation, you can reach to the differential equation, or in the differential equation, you can put the required values, and then you will be able to verify that the given differential equation has this solution or not. I mean, from the solution, we can directly reach the differential equation also. In each of the previous part also, we could have reached to the direct differential equation. But instead of that, I tried to use another simple approach, which is basically you just calculate y dash, y double dash, whatever is asked, and you put that. Otherwise, you would have find out y dash here, and to solve this, you just put y dash in this equation, you will get the required result. Right? So this is one portion where you will have to verify whether the given function is a solution of the given differential equation or not. Right? Now, the next topic is how to form a differential equation So this is the main question. The third topic that we will understand is how to form a differential equation whose general solution is given. So let's say if you're given the general solution and you have been asked to find out the differential equation of that solution, then how do you find that out? So it is also easy, but you will have to understand first how are we using the general solution to find out the differential equation, right? So the important actually statement in this is this basically the order of a differential equation, the order of a differential equation representing a family of curves representing a family of curves is same. First, just write this. I'll make you understand what we are saying. Is same as the number of arbitrary constants present in the equation corresponding to family of curves. Right. So basically, what we are saying is you will be given a general solution, right? And from that general solution, you have to form a differential equation. So to form a differential equation, first of all, the basic, I mean, the first basic idea that we need to get is up to what order this differential equation will be defined. Mane, how many times I have to differentiate the given solution? You will be given a solution, basically. So general solution, mane, you will be given a function or you will be given a basic equation, right? And from that basic equation, you have to form a differential equation. and differential equation will only be formed when you differentiate with respect to x, right? So the important question will be, how many times do I have to differentiate? One time, two times, three times? I mean, up to what order my differential equation will be defined? So this order will be defined by the number of arbitrary constants present in the general solution, right? Okay, so for this, I'll give you an example. So example is to form the DE of the family of straight lines. Family of straight lines money. We are talking about the general equation of straight line. We're talking about all the straight lines. Okay? So the family of straight lines is represented as mx plus c, right? So if I'm given this general solution and I have been asked to form a differential equation of this general solution, so in this case, I can represent this question as that I am finding out the differential equation of the family of straight lines, right? Because this equation represents straight lines. Generally, this is a general equation of straight line, right? So I'm basically trying to find out the differential equation that represents all the families of straight line, right? So to find out that differential equation, I need to know up to what order I need to differentiate this equation. And that order will be decided by the number of arbitrary constants in this equation. For example, in this case, y is equals to mx plus c. Okay? So here m and c, okay, start with this. We have used, right? We have used two arbitrary constants to define the equation, which are basically m and c. We have used m is also constant, c is also constant, right? But they are arbitrary constants. So in this given equation, we have two arbitrary constants. It means, it implies that the differential equation of family of straight lines of family of straight lines has order 2. The order of this straight line, I mean, order of the differential equation of these family of straight lines will be 2. This is definite. Why? Because we have to use two arbitrary constant to define the equation of a straight line. Without m or without c, we can't define this equation. We have to have used these two constants, these two arbitrary constants. That is why we can say that the differential equation of this straight line will have order 2. Now let's try to find out that differential equation. Okay, let's first understand through some examples, and then we will also talk about the algorithm. I mean, this is the algorithm, but we will understand the algorithm with some examples. So let's try to find out the differential equation of this only, right? So for that, I will have to first find out the order. Okay, up to what order I have to differentiate the given function. Like in this case, as we are using two arbitrary constant, it means that I have to find y dash and I have to also find y double dash. So let's form let's also talk about formation of D. So for formation of D, we have the equation y is equals to mx plus c. Two arbitrary constants. Two arbitrary constants mean find y dash and y double dash. Right? So which means that y dash is m, right? Because y dash is dy by dx. If I differentiate this left hand side with respect to x, this will be dy by dx, which is y dash. Right hand side will be mx will be m plus c. C is a constant, so it will be 0. Right? So this is my first equation. And then also find y double dash. So again differentiate this. This is a constant, So y double dash is equals to 0. Right? Now use these two equations. Okay, use these two equations to eliminate m and c from here. Right? Use these two equations such that we don't have to write m and c in the differential equation. So like in this case, you can see that y double dash is equals to 0. This is a differential equation. This is a differential equation which is basically representing the family of straight lines. Y double dash is equals to 0. This is the required differential equation. Why? Because this is not using m or c, right? We are neither using m nor using c to represent this differential equation. So the simple algorithm is, just give me a minute. Yeah, sorry. So the simple algorithm is that first figure out the number of arbitrary constants, find out the order, find out the number of times of constant derivatives, है ना? जितने भी, if there are two arbitrary constants, then we will have to find out up to second order derivatives, right? Find out those derivatives and then eliminate these arbitrary constants using these equations. Then using these two, eliminate m and c. Right? This is the simple algorithm. For example, in this second case, we don't even have m or c. That is why we don't even need to eliminate them. But in the further cases, this is the easiest differential equation actually. So, but in the further cases, you will be asked you'll be asked difficult questions in which you will have to understand how to find out the final answer for differential equation. In the final answer, there will be no m, there will be no c. There will be no arbitrary constant which were used to define the equation, right? So let's also find out some of the so let's first just write the basic algorithm which works like this. So step one is First of all, let's find out total number of arbitrary constants. Let's say these arbitrary constants are k. There are k different arbitrary constants are used in the given equation, right? Or rather than k, we can also take it as n, right? Then second will be find find up to nth order derivative So find up to nth order derivative. So let's say you have two constant, then you have to find up to second order derivative. In that case, you will get two equations. One is for first order derivative and another is for second order derivative. So let's say you have n constants, in the general solution, then you have to find out up to nth order. So if five constants, then I will have to find out up to fifth order. And if I find out up to fifth order derivative of the given function, in that case, I will get five different equations, right? So that is what I have written here. Find up to nth order derivative, there will be n equations formed. It means if you will find out up to nth order derivative of the given general solution. And then third step would be use these n equations to eliminate the n arbitrary constants form an equation in which there is no arbitrary constant, right? Using these n equations. The final differential equation, this is an important point, will not contain arbitrary constants. All the arbitrary constants must be eliminated using these derivatives. Right? So this is the basic algorithm. Let's try to use this algorithm on few examples. Yeah, let's start with this. Form the differential equation representing the family of curves first part. The first part is y is equals to a times sine of x plus b, right? Where a comma b are arbitrary constants. So you will be given a question like this, in which you will be given a solution. Basically, you will be given an equation, and you will have to find out the differential equation of that equation, right? You will be told about the arbitrary constants. If not, then you will assume other than x and y, everything is arbitrary constants. If not given, then anything other than x and y is an arbitrary constant, right? Any alphabet, any number is not. Okay. Yeah. So in this case, a and b are arbitrary constants. We can clearly see that there are two, as there are two arbitrary constants involved. Find, it implies that find up to second order derivative. Right. We have the equation. We will have to find out up to second order derivative. That is, first we will find out dy by dx, then we will find out d2y by dx. Right. And using these two equations, we will try to eliminate a and b. Right. And if we are able to eliminate a and b using these two equations, then we will get our required differential equation. Okay, so the given equation is y is equals to a times sine of x plus b. Right? Now, if I find out y dash, then y dash is a is a constant, right? So a is as it is. Differentiation of sine is cos of x plus b, right? Then again y double dash. Y double dash will be a same. Differentiation of cos will be minus sine x plus b, right? So now, can you tell me how to eliminate a and b using these two equations? I mean, using these three equations. This one equation is already given to us. These two we have formed. How to eliminate a and b using these three equations? Anyone? We have the direct answer. Just look at it. We have to eliminate a and b. Okay, focus on first and third equation. Okay. Third equation is just the negative times of first equation on the right hand side. If you observe, this a sine times sine of x plus b is equals to y. This part is the same. This is a times sine of x plus b. This is also a times sine of x plus b. What is a times sine of x plus b? Y. So using 1 in third, I can write this portion as y double dash is equals to minus times of y. No? So this can be written as y double dash plus y is equals to 0. Guys, just give me a minute. Yeah, feel free to ask me your doubts. But this is how we can form a differential equation if a general solution is given. If anybody is left, then just raise your hand. Okay, cool. Okay, find out the differential equation for this. There is only one constant. These are two questions. Feel free to ask me your confusion or doubts, and please try to solve them. I mean, there is only one constant involved in this case, so we will just have to differentiate this one time, and we can very easily get the differential equation for this. Please try to solve this fatafat and tell me the differential equation. हाँ जी, नहीं हुआ. Differentiate this one time. 2y into y dash, and this will be 4a, right? So you get the value of a, na? What is the value of a? You directly get the value of a. Value of a is, if you take 4 to that side, the value of a will be y into y dash upon 2. बस हो गया eliminate. Now use this equation in this. I mean, this is also an equation given to us, na? So one equation is this. With this and this equation, eliminate a. Very easily we can eliminate a. We could have divided them also, like we did in the first case. We just divided the first and third equation. We will get y upon y double dash is equals to -1, which is same as this. We could have also done that, but directly also we got the value of a. Put this in y square is equals to 4x. So it implies that, or we didn't even need to calculate a. We could have directly calculated 4a only. Okay. Now the value of 4a we know. So use this in this. Y square is equals to 4a. In place of 4a, use 2y into y dash into x. Right? And this will be, you can cancel 1y with 1y. So y is equals to 2y dash x, or y dash is equals to y upon 2x. And then we can write it like anything. This, or our same thing. Yeah, please also solve this one. X square plus y square plus 2gx plus 2fy plus c equals to 0. This is also the last question of the class today. And your homework will be exercise 9.2 and 9.3 after this. I believe that you will be easily able to solve both of the exercise, but feel free to discuss your doubts. Now you can see that there are three arbitrary constants. So you will have to differentiate this 3 times. Okay? The first differentiation will be 2x plus 2y into y dash plus 2g. Differentiation of x would be 1 plus 2f y dash is equals to 0. This is the first differentiation. Right? Then the second differentiation will be again 2 plus 2 times. Here we will have to apply product rule. Differentiation of y will be y dash. Y dash is as it is. So this is y dash whole square plus y is as it is. Differentiation of y dash is y double dash plus differentiation of 2g will be 0 plus differentiation of 2f y double dash. But as there are three arbitrary constants, so we will have to differentiate again. Right? So differentiation again can be, this is differentiation of 2 is 0 plus 2 is as it is. Now differentiation of this first power, so power will be 2 y dash to the power 1, then y dash, so it will be y double dash plus, then we will go to second term, right? Second term will be done by product rule. So this will be y dash into y double dash, first differentiation of y, which is y dash, then y double dash is as it is, plus y as it is, this will be y triple dash, right? Plus 2f y triple dash is equals to 0. Right? Now, you can see that in second and third, you only have f. So you can find out the value of f from second and put that in third. So from second, the value of f would be, okay, I'm going to find this out. This will be y dash whole square plus y into, okay, so you can also write it like this: y dash whole square divided by y double dash plus y, and this whole term will be with the negative. So the value of f from the second equation can be found out. This will be this, and use this in third. So if we use this in third, this will be twice. Let's multiply them, all of them actually. So this will be 4 y dash y double dash plus 2 y dash y double dash, right, plus 2 y into y triple dash plus, this is nothing but 2f, right? So twice of, we know what is f. F is with the negative sign, so I'm applying negative here, and this will be y dash whole square divided by y double dash plus y into y triple dash is equals to 0. So this whole equation actually, can be written with some more adjustment. So this will be 6y into y double dash plus 2y into y triple dash minus, we can multiply this or we can take this. Okay, so the final equation will be this. I'm actually writing the final equation. 4 times y, sorry, 6 times y dash y double dash whole square, yes, plus 2 times y double dash y triple dash minus 2 y dash whole square y triple dash minus 2y into y triple dash is equals to 0. This will actually be the final differential equation for this. So this will be your final answer. So, please write this, okay?